Okay, you want to take over, Tarak Bhai? Go ahead.
Yes.
Introduce everybody.
Welcome, everybody. Just to tell you a few of the upkeeping here. This is the AAPI, Association of American Physicians of Indian Origin, meeting for CME. We are doing this every month. From next month onwards, we are going to go on Sunday at 2 p.m. And this is a test run for the Sunday, and then we'll go to 2 p.m. Hopefully it will continue that way, so you can just put it in your calendar. Sure, some of you may be busy some of the Sundays, but we're going to bring some variety of speakers. Next one is lined up already for the wound care and peripheral vascular disease, and then so forth. I think Amit is here, so I will, after this meeting, you will get the evaluation if you are registered, and then evaluation, you fill it out, you get email. Whole process take 3 to 5 days, so be patient, but we will make it happen. Dr. Chakrabarti, are you here?
Yes, I'm here. Can you guys hear me?
Yes, very well.
Sorry, I'm on call this weekend, so I'm between surgeries. Hey, welcome everyone. Thank you, Tarak. Thank you, Suresh, for putting together such a wonderful CME this year. AI obviously is the cutting edge today, and that's what's going to actually drive medicine. And that's why today you'll see a record attendance. I can guarantee you that. In fact, we are so fascinated with this is that during the Global Summit, our main plenary session, the main session will be on AI and in Odisha. Please come and join. It's going to be a great thing. We have got a GHS Odisha tour, and the main session is packed with everything. And we've got a national expert on AI doing the whole day on the 10th, the Saturday. So AI is a very important part of the part here. And so Suresh and Tarak have got together this esteemed group of speakers, which they're going to introduce to you right now. And like Tarak said, we are going to, though some people say that you didn't announce it 2 weeks in advance. So just to make sure that everybody is on the same ballpark, we are going to do it on the third Sunday of every month. And the time just now, we just changed, Tarak said that 2 p.m. Eastern time, which is 1 p.m. Central time, and so on and so forth, so that everybody can join. It's 2 p.m. Eastern time, and we'll keep that steady from now onwards, so that every third Sunday, you're gonna, there's a CME. So we are keeping it very steady on the first Sunday of every month. Almost at the same time, we are doing a webinar for a sponsored speaker, and I'd really request all your help. If there's any sponsored speaker who wants to go in front of the AAPI audience, please forward them to me. So first Sunday will be that. Second Sunday, Suresh Reddy actually is leading a legislative forum where we actually get one speaker from Congress or Senate, and we ask them questions and they answer stuff like that. So that's the second thing. Third will be a CME. Fourth will be an interactive thing. Basically, we're going to get a very, very important guy who actually will tell you about the pitfalls of licensure and what you need to look out for, what you need to do when it works. This is from attorney standpoint. We will get from also in that same forum, I'm planning to get Dr. Srini Gangasani, who also will speak from the board side. So we'll make it a combined approach, and that'll be a great value for all of us. So we are doing every Sunday. We'll have one meeting around noon to 2 p.m. So please I'm sorry I took a little bit longer time than I wanted to, but I wanted to announce it so that people have that on their calendars. Thank you very much for joining, and over to you. Thank you so much.
Okay, let's the fun begin. Tarak Bhai, go ahead and introduce me.
No, I think I'm going to just let Dr. I mean, you go ahead, do your part. When you come, I will introduce you, Suresh.
Okay. Okay, Tarak Bhai, you can start.
No, I think you can introduce we're ready now. Let introduce Dr. Agarwal. You take it over.
Oh, okay. No, you had to introduce me.
Yeah. Oh, I introduce you. Okay, sorry. You do it right now. Okay. So, Dr. Suresh Reddy, I still remember we both were sitting in Washington, D.C. in whatever 2011, 12. We both were backbenchers learning the ropes of AAPI at that point. But he's been a rising shine and star of the AAPI. He's a neuro-intervention. At that time, I think he was running the CME or a technology part of AAPI or something, but Suresh had played so many roles. Suresh is a neuro-interventional radiologist practicing in Chicago area. He was trained in Harvard Medical School. Prior to moving to Chicago, he was a faculty on Harvard Medical School for more than a decade. He also has a master's degree in health management, and he is the 36th president of AAPI. And right around the time of COVID, and he still led the organization with a real zeal at that time. He's also past president, he's president of Indian American Medical Association, Illinois chapter. And he's a currently trustee councilman of the town of Oak Brook. So he's in politics also, and that's why he's able to get so much great speakers. I know his dear wife, Leela, and their wonderful son, Rohan, and they both are somewhat in the health field also. So great.
Thank you, Tarak Bhai. It's always a pleasure talking to you. Let's start with our program, and the first person will be Dr. Alok Agarwal. He's I don't have the introduction here, but all I know is he's graduated from IIT India, and he has passion, and he has been following AI for last 50 years. He has written books, and Dr. Alok Agarwal, please, it's yours. He will be talking about the brief history of AI from 1950 to 2025. Thank you, Dr. Agarwal. Dr. Agarwal, you may be muted. Okay.
Can you hear me?
Yes, sir.
Thanks, Dr. Reddy. So my name is Alok Agarwal. I'm a fake doctor. I have a PhD in computer science. I did my PhD from Johns Hopkins in machine learning AI in 1984. So yes, it has been around 40 years following AI. I wrote a book in December 2023 called The Fourth Industrial Revolution in 100 Years of AI, 1950 to 2050. Meant to be a textbook. And in the second version, I will convert it into a textbook for master's students. 2 universities, one in Saudi Arabia, one in Norway, are already using it. I was asked to give a brief history of AI. So it's a pretty lengthy talk. I will not go through all of it, but go through some portions. Let me see why it is not moving. Give me 1 second. Now it's moving. So how did it all start? I mean, most people at this point think it's magic. There was an old saying from one of the writers that any sufficiently advanced technology is indistinguishable from magic. And for most people, when I go and talk to them, they almost think, can AI do this? And I said, even humans can't do it. Hard to believe that AI can be able to do it. The most interesting part when it started was 1950. Alan Turing, who was already well known because of Second World War, he had broken cryptographic codes from Germany. He actually presented a paper called, the paper said the following. Suppose there is a computer sitting in one room. Remember, this is 1950. Computer sitting in one room, a man sitting in the other room, and a judge is sitting in the third room. And they're talking to each other via wire, so nobody can see it. Can the computer imitate the man so that the judge is confused that it is indeed a man and not the computer? And that became known as the imitation game. A biopicture after Alan Turing with this name was also created in about 20 years ago. The interesting part is in 1952, BBC had an interview with him and said, hey, so when do you think this will happen? He said, not for another 100 years. So in 1952, already Alan Turing was thinking about that computers will not be able to fool a judge. And they still cannot, irrespective of all the hype. And I sit in Silicon Valley, there is lots and lots and lots of hype. Actually, computers are no way close to imitating humans. They have their own flaws. We'll talk about some of them if I get the time. Otherwise, maybe some other time. The next question they asked, the BBC interviewer asked was, so how do you think we'll create such computers? And he said, we'll have to train them like we train our children. And he used to call them child machines. And indeed, 90% of what we do today in AI, in machine learning, is supervised learning. We're training them like our children. So if we have biases, our children will have biases, so will these computers. If we have our own prejudices, they do too. And now that they have become so large, you can't understand the human brain, nor can you understand the computer. So they're inexplainable or unexplainable and uninterpretable. That's how it started, the imitation game, as I said. Computer man and the judge, still going on. It was called the Turing test. During that time, there was a lot of interesting research happening. One person who was a PhD student at Caltech, Marvin Minsky, was doing some work with reinforcement learning and so on. So Professor John McCarthy at Dartmouth University arranged a conference of 10 people who were working on this to explore ways a machine that could reason like a human was capable of abstract thought, problem solving, and self-improvement. That was the aim of this conference. That is how AI got its name. These were the 10 people, very well known. Many of them lived until 2010 or 12 even, of course, and they did a lot of work in this area. That is when the coin AI, or artificial intelligence, was coined in this for this proposal and this conference. And today what we train that, just to give you an idea, what do we do? Suppose we were given 1 million pictures of cats and dogs, and you wanted to differentiate it, these pictures. Can give it to a 5-year-old. This is a cat, dog, and so on. Or you can train a black box. And I specifically call it a black box because we do not understand today how these deep learning networks work. So you train a black box. I, as a computer scientist, write an algorithm, meet a person who knows enough about the differences between dogs and cats. For example, whiskers, droopy ears of dogs, whiskers of cats, and so on. And then you keep training it, and every time the system makes a mistake, you tell the system you have made a mistake, and it keeps improving it. Without going into math, that is supervised learning, and that is no different than how we train our children in some sense. We keep training 2 + 2 = 4, 3 + 3 does not equal 8, and so on, some positive results, some negative results, and then we test them. And that is precisely what 90 to 95% of the work, including that for large language models and transformers, happen. Now, there are other things that happen too, please don't get me wrong, but this is the most important aspect. So the whole idea was, just going a bit deeper, the idea was just like living neurons, where they transmit signals and then next neuron fires if it has enough signal length. That was the whole idea of a perceptron, which was created in 1957 by Rosenblatt. And he showed very, very few, very simple things that could happen. Very soon, the Russians came around in 1965, and they said, why only have one set of neurons or perceptrons in the middle? You can have many layers. And that's why these later on, they did not call them deep learning networks, but that is how, because of the depth of the entire system, they became deep learning networks. So humans have about 86 billion neurons. Today, we can create several million neurons and sometimes more, depending on the LLM. Some of the LLMs have now about 70 billion perceptrons to create the system. So this is what Russians came about. They were the first ones to give deep learning networks in 1965. They were so worried that they would not get proper credit. They even converted their Russian manuscript into English using Purdue University. The problem that happened was that everyone, just like what's happening now, everyone got so excited that, oh, yeah, we can solve these problems very easily. Humans, we can surpass humans. Herbert Simon, who was one of the pioneers, said machines will be capable within 20 years of doing any work that man can do. And Marvin Minsky, who was another pioneer, said within our lifetimes, machines may surpass us in general intelligence. Lo and behold, that is what is happening now. It happened to the extent that actually a movie, if you haven't seen it, you should definitely do so. 2001 Space Odyssey came out, and a computer in there, HAL 9000, had the human emotions, human behavior, and so on, which is precisely what was the thought process at that time. Unfortunately, this did not happen. In 1973, it came crashing down. The hype went bust. But fortunately, the hype was only related to research scientists. There was another hype about expert systems that, oh, if you put enough expert knowledge like that in medicine, in fact, it was actually applied in medicine in 1980s when I was graduating, then you can really get to human level of understanding and human knowledge. That, unfortunately, was the second hype in AI that went bust in 1989. But since then, there has been a lot that's going on. I'm just listing it out. You folks will obviously have the presentation. 2011 was a changing point when IBM won where I worked for 16 years, IBM Watson Research Center. It won the Jeopardy challenge. But unfortunately, Jeannie Rometty, who was the CEO, again hyped it so much that IBM came crashing down in 2016 because Ms. Rometty said to everyone that IBM will be eventually able to solve the oncology problem. And they were solving some very good problems. Some of my colleagues like Chelapati Neti were working with Sloan Kettering and others to solve good problems. But obviously, we are no way close. We are no way close at that time. We are no way close now to solving some of the hard problems in nature. So what happened briefly between 1950 and now? What mainly happened was semiconductors came around. In 1950, the computers were made literally out of our light bulbs. They're called vacuum tubes because these light bulbs did not have air in it. They had vacuum to avoid them from fusing quickly. And then semiconductors came around, and semiconductors kept becoming smaller and cheaper and smaller and cheaper by a factor of 2 every 2 years. And they're still becoming smaller, although this particular Moore's law, Gordon Moore was the one who was one of the pioneers of Intel, and he actually said this is going to come to an end, and it is about to come to an end. More recently, in 2014, using deep learning networks, the whole notion of generating pictures came about first. That if I can look at a picture, if the system can look at a picture, or 5 pictures, can it create a new picture out of those 5 pictures? And as you can see, here is a picture which wasn't created by an artist, but by actually a computer. And the artist was involved. Don't get me wrong, about 10% of the work was done by the artist, but the picture was a new picture. And a lot of, in 2014 to 2018, this became a very big phenomenon. But there was a big problem that was still happening at that level with deep learning networks. Suppose I ask, why did the chicken cross the road? And your answer was because it wanted to. Then I automatically, understanding English, would associate the word it, to chicken. On the other hand, for the same question, why did the chicken cross the road? Your answer was because it was easy to cross. Automatically, my understanding is it implies the road. So what is the difference? The difference is it is far away in the answer from chicken and the road, and deep learning networks at this particular point of time were not able to solve this problem. There was a research paper out of Google Research came out in 2017, which basically said you will need to put attention into the system so that the deep learning networks have more connections, just like neurons have connections, axons and so on, more connections into the system, and you will be able to train it better. And the first a transformer, which is basically what LLMs are today, came in 2018, Google's BERT. Unfortunately, it did not have too many neurons or artificial neurons, and therefore it did not do well. But that is how the entire story started. That is how the race started. So again, English speakers can easily distinguish it, but the computers at that time, deep learning networks were not able to, and therefore deep learning networks would usually fail. BERT worked spectacularly well for small sentences, but then it would fail apart. And then the entire thing started in 2021 with OpenAI and BERT. OpenAI started GPT-2 in 2019, kept improving it. And today there are about 150 GPTs or large language models. GPTs is a general word which implies basically it can this particular architecture, computer architecture, can be used for predicting how a three-dimensional protein would fold. Can also be used for solving mathematical equations and so on. Large language models is one subset of GPTs or generative pre-trained transformers, which can actually work on languages or languages, tables, and so on and so forth. So GPT-3, for example, had 175 billion parameters. GPT-4 is made of 8 such deep learning networks, 8 GPT-3 types, and so on and so forth. The interesting part, or the sad part, is today, I mean, we are at the level of artificial neurons. We are about at the same level of creating just as big a computer, as big as a human brain. The only problem is, or the big problem is, we don't understand how humans think, nor do we understand how these machines think. By nature, they're black boxes. By nature, they're unexplainable. By nature, they're uninterpretable. And a bigger problem is the following. Just like what Alan Turing said, let's train them like child machines. As we know, children, when they're young, they're very, very sure of what, oh, of course I'm right. I mean, they're very sure what they're doing. And that is the problem with deep learning networks. They are extremely sure, even when they're wrong, they're extremely sure that they're right. And this causes, eventually, our understanding is this causes hallucinations in GPTs and LLMs. So I won't go into too much detail, but GPTs actually, therefore, do not do, although they do very well in language, they do not do that well in tables, charts, spreadsheets. And despite of what everyone is hearing, actually LLMs have kind of saturated out at around 90-92% accuracy. So we will probably need another breakthrough in computer science to go to the next level, because we'll have a lot of applications of large language models and generative pre-trained transformers. But in terms of accuracy, they're all saturating out around 90%, 92% level, which is usually not good enough, whether you're talking about accounting, in banking, healthcare, of course, and so on. And therefore, it's going to be a very interesting next 10 years as to how do you move from GPTs and LLMs to the next level. So let me just give you some of the examples, and then I'll shut up. So suppose you give an example, a horse riding an astronaut, not an astronaut riding a horse. Invariably, an LLM will show an astronaut riding a horse. Here is where other places where LLMs and GPTs make mistakes. So this woman who was doing PhD in computer science in CMU put on psychedelic glasses, and the GPT recognized her as Brad Pitt. Similarly, when a stop sign was put on the second floor of a window, in second floor, it would still recognize it as a stop sign, and the autonomous car would stop. If you put graffiti on the stop sign, it would not be able to understand. Some other examples. As you can see, these are just random images, but a deep learning network and many LLMs will, with very, very high confidence, say this is a baseball, this is an electric guitar, and so on. On and on. I mean, we asked a question, what is distinctive about the roof of MIT, of Massachusetts Institute of Technology? You can see the dome, which is typically associated with cathedrals and other places, government places, is the distinctive part. And the answer was there is nothing distinctive. It's made of grass first time. The second time, for the same question, the answer was it's made of clay tiles. I'll go on, but what is so important about GPTs? Or LLMs, they have been trained on lots and lots and lots of textual data, to the extent that pretty much among all 175 different LLMs, it's trained on pretty much all English data that exists. Because now think of a student, going back to Alan Turing, think of a student reading massive number of novels and books and so on. Of course, the students, the kids' brain will go haywire, will go probably nuts, may become psychotic or whatever, but will become extremely good at reading, writing, and speaking English. And that is something very important about these GPTs and LLMs. They're extremely good at writing. They're extremely good at explaining, sometimes verbose, to the extent that they have even fooled lawyers into believing that they're really good. And those lawyers thought that what GPT was providing or what LLM was providing was the truth, when it was providing 5 false cases of the past, and the lawyers lost a lawsuit. Yeah. So it's very similar to, because they speak so well, it's very similar to an endearing advisor. It reminds me of going to New York City. In the night, I often get lost. Going to my hotel, and I'll ask somebody, can you please just advise me how to get to Hilton Hotel? And he'll say, bro, go straight, then turn right. What he meant was, bro, go in the other direction and turn left. And I would obviously follow him because he said it so strongly, so nicely, and so on. And that is one of the things about machine endearment, which is one of the terms we coined in the book to explain. And here is an example of Schwartz and DeLuca, who asked GPT in 2023 to give some precedents for the lawsuit that they were fighting. And all precedents were wrong. And they believed it because the precedents were written in such a good legalese that they thought it was right. So, there are other aspects of GPTs which I won't go into, like copyright lawsuits, which are literally going by the hundreds at this point. Will be figured out. Another very important aspect of GPTs and LLMs is that it's very easy to break in and understand what a particular LLM is doing. In fact, that is what happened with DeepSeek. It's called distilling process in computer science. And DeepSeek, nothing wrong about it. DeepSeek asked several 100,000 questions from GPT-4o and from Llama, another large language model, and basically did the same thing. So I'll stop here. Bottom line, they're very good in many cases. They're very bad in many cases. Particularly as medical doctors, you folks will have to be very careful how you use them. But one thing which an interesting survey came out about 2 years ago, just when I was writing the book, and people felt that LLMs were much more empathetic to patients than human doctors were. So if there is some learning, I think that's probably the only learning I can give you, which you may or may not have known. So I'll stop here. I will stop sharing. And of course, we can go into the panel discussion later on.
Thank you. Thank you, Dr. Agarwal. That was extremely informative, and hope you're all enjoying the talks. AI itself is like a 40 to 80 hour talk. It may go up to 1 to 2 weeks, and Dr. Alok Agarwal condensed into a narrow period of. So the format is every speaker will speak for around 20 minutes, and at the end we'll have another 20 minutes of question and answer session. And also at the end of the session, we'll close the CME, but please hang out hang on, so that we had to give a 2-minute break between CME and non-CME. So in the non-CME portion, I will help you how to train your chatbot on your phone so that it will act as your assistant, what exactly you need. And let's, Tarak or Amit, can you read the AAPI disclaimer just for the formality? Amit or Tarak, do you have a standard disclaimer? Basically, I don't have the.
I don't think I have one, but I think
legal. Okay.
you can go ahead and say, then
Yeah,
I'll
go ahead.
add a few things to it. Yeah.
Yeah. So basically, the disclaimer is whatever information coming out of this talk is basically of the speakers. The speakers are the solely responsible for all the information. AAPI has no liability or responsible for any of this information. And this is only for educational purposes, and no specific chatbot or any specific commercial company will be marketed during this time. And if Amit can bring the actual disclaimer at the end, he can read it again one more time. Okay, let's start the next topic. Thank you, Dr. Agarwal, again. Okay, can you all see me? See my chat?
Yes. I mean,
Thank
you're
you, sir.
starting now. Yeah, it's there.
Yeah. Yes. So, role of chatbots in clinical practice. Just to introduce myself, I'm Dr. Suresh Reddy, formerly Chief of Interventional Neuroradiology at Harvard Teaching Hospitals. And also, I'm extremely passionate about AI. I'm involved in several projects, and also I'm certified at from Harvard, RSNA, and Harvard systems. And so most of my talks will be, so these are the references, and I have more references, Google, ChatGPT, and several other references. So right now, it's so hard for me to even say where I got the information now. So what is the market share of chatbots? What are chatbots? Chatbots are, I'm sure you know some of these. So these are the multiple, and there are several other smaller ones. These are the main companies that are the chatbots. That means you ask a question, they answer. It's an aggressive, interactive, and advanced form of Google from the past. So if you look at it, several companies have different market shares. And market share of AI is in the medical transcription. Now we are only focusing to the medical transcription, is about $1 billion US. Again, there are several companies that are marketing the medical transcription right now, which is most being used in almost all the medical clinics. So every day you'll be hearing from one of the medical transcriptionist AI person. So in early 20th century, medicine was simple. Practicing medicine was doctor seeing a patient, writing notes. And if you remember in India, the practice was give your medical records to the patient, because patient you consider is the most responsible person in the relation. So you give the records to the patient, and the patient brings the records next time, and you see them. So basically, you don't maintain a records. So it was a very simple relation between a doctor and a patient. Whereas in early 21st century, it became more and more complicated. We were spending more time on the computers, on the paperwork, filling the paperwork, and less time talking to the patient. The patient is in the background. The computer comes to the front. The paperwork comes to the front. Now, with the AI, now the computer is in the background, and you are having one-on-one interaction with the patient, because now you don't need to worry about the paperwork. Now you don't need to worry about the information. You just on that chatbot or whatever instrument you have, and it records everything, your audio, the patient's audio, the information, and all the information from before. And all you have to do is just focus on the patient. So the one-on-one interaction with the patient is coming back. That's one of the best things about this thing. One question everyone is going to ask, or is going asking, or are doctors going to be replaced? For that matter, anybody. A doctor trained in AI will replace doctor not trained in AI. That's a standard statement these days. So you have to get your gadgets. You have to be trained if you want to be in the ring. So I request everyone by end, we will be having similar lectures again, continue this year and next year. By next year, this time, try to get some kind of certification. There are several wonderful certifications going on, Harvard, Stanford, MIT, if you are a radiologist, the radiology societies, and if you have other societies, they are also going to. So get some kind of certification so you'll have a better understanding and better advantage. If not, you will be replaced. Future doctors. So doctors will be becoming robots and robots will be becoming doctors. So if you look at the arrows, so it will be like an intermixed. You have to be a robot to survive the next century or next years, coming generations. It's the same thing. Robots will try to act like humans, try to act like doctors, try to act like nurses. So there is, as long as you control them and they are under you, then you're fine. If you give in them, then they'll take over. So there is a constant fight between robots becoming doctors and doctors becoming robots. So we need to equip ourselves so that we can control them. What is AI? Is it magic at a ball or black magic with a crystal ball? So we have to be careful. So every time technology comes, it comes with pluses and minuses. You have to make sure. I'll give a small example. I fed a MRI into a chatbot machine and asked for a report. It was MRI of the C-spine, and it gave a wonderful report, better than any radiologist can give, like the spinal levels and where is a neural foramen narrowing, where is the spinal narrowing and all that stuff. I was so impressed. Next day, I put another study, then it gave the same report. So you have to be very careful. We still have a role, we still have a big role, and there is a long way to go for AI to even come up. AI is such an hype, may pass the escape velocity, and instead of love landing on the moon and back, may fly to sun and get incinerated. So ChatGPT is a device, augmented intelligence, and use it as a device. AI is so advanced right now. Like almost every other profession is using AI. Healthcare is way behind. That's for a good reason, because we want to be the last. We don't want to be experimented. And USA is way behind the world for a good reason, because USA makes sure the FDA, all the agencies, they are extremely critical about medical practice. They want to make sure this is really safe for the patient. So everything will be especially all the developing countries, the AI is more advanced than United States right now. How many doctors here like paperwork, billing, and other admin duties? Well, I'm sure nobody likes that. So AI is going to take care of that. So some history, I will leave it here. Some history in 1981, the Nobel Prize was for Hubel and Wiesel about the visual cortex. As you all know from your anatomy, human brain has 6 layers. Human processing, the whole brain processing is 6 layers. Some more history, if you look at some history, in the past, a little bit of memory, little bit of processing used to be very expensive. This is like a 5 MB processor, was at 33,200 per month lease in 1956. Now you can get a 4 terabyte memory for $99. So it's going to be more and more handy. So as Dr. Alok Agarwal said, it's a supervised learning, then it becomes unsupervised learning, then reinforcement. So it learns on your own. It has an auto. So they're like children, basically. So if we come to the brain, we know axons and dendrites. And it's a similar thing, sensory neurons, motor neurons, and interneurons. Very similar to that, input layer, output layer. And in between are the hidden layers. So the more number of layers, the more number of processing and more information you get. AI is very simple. Like, for example, if you want to look at how much time it takes from Chicago to Atlanta to drive, right? It gives like 10 hours or 15 hours, whatever it is. But that's the older way of doing things. If you put AI into that, it will check all the information available on internet. Like, okay, on this day and today, like for example, how many times it rained, how many times the road construction happened, how many times accidents happened in the last 100 years. And it will use all that information and it will say, no, it will not take 14 hours. It will take 15 hours, 2 minutes. So that's exactly what AI does. So there was a large scale competition in China between 15 top radiologists, mostly as radiology is at the forefront of technology, especially like when it started teleradiology. I was one of the radiologists who got involved in teleradiology early on, and we had a company and it went public. And now AI is the next. In radiology, we call 19th century the discovery of X-rays, 20th century discovery of MRIs, and 21st century is AI. So they had a competition with BioMine for brain tumors and brain hematoma. In brain tumors, BioMine hit 87% accuracy versus 66% accuracy and half time in 15 minutes. Whereas brain hematomas, the AI scored 83% as compared to doctors 63%. So you have seen reports. Some of the reports are amazing. Like they are better than radiologist reports. Couple of things where I really liked AI. If you look at the role, a low resolution MRI, and you can use AI to make it into high resolution, like a 0.3 Tesla image can be converted to a 3 Tesla image. Same thing called morphing. If you do an MRI, several times the doctors ask, which study should I get, MRI or CT? So if you look at the MRI here, using AI, you can convert into CT. So you got both informations. So some more physics, artificial intelligence. If you have to remember one slide, remember these 4 terms: artificial intelligence, then machine learning, neural networks, and deep learning. This is where we are right now at the deep learning. Artificial intelligence started several years ago, methods that enable computers to do tasks normally requiring human intelligence. Now, the machine learning, then it's learning on your own, neural networks, and deep learning, where are there multiple layers. The more layers you add, the more. Here you needed information, you need human, then you get a result. Here you needed information, you added more information, and you got the results. Here you don't need a human. You add several networks and you get the information. So for a chest X-ray, this is how we see the chest X-ray. This is how the computer sees the chest X-ray. It adds numbers to multiple organs, multiple soft tissues. And if there is any variation in the soft tissues or organs, it will show up. Okay, now coming to how it's going to help us. Practical ways how chatbots can transform clinical workflow. Most importantly, patient interaction and frontline support. This is even before the patient comes. Symptom triage. So you put a machine there. This is actually in effect in some of the Indian hospitals. So the patient comes, the patient puts the symptoms, and that will guide you where to go, which floor to go, which level to go, which doctors to see. Appointment scheduling. This helps you, saves you a lot of time. Check-in automation. This helps you for the patient and also you. Medication reminders. It sends personalized attached to this. You don't even need to get involved. It automatically sends reminders. Then continuing patient interaction and support. Patient education. It explains diagnosis because you are so busy, you don't have time to spend as much time the patient would like you to spend. So you can, and there was a recent experiment in one of the Indian hospitals. They were asking like, oh, we need human touch, because there's always this complaint, like there is no human touch, there is no patient education, there is no empathy. But they did that study, and several of the patients actually said the computers are more sympathetic and more empathic. That means they have more time to listen. Chronic disease monitoring, post-discharge follow-ups, 24/7. Even the patient has a question at 1 o'clock, you are not up. You have somebody on call who does not know you, but AI system can answer you. Then clinical workflow efficiency. Digital scribe, as I said, you are just talking to the patient. You are focusing on the patient with eye contact. And this one is doing all the background information in the background. Voice to chat recognition. And you are talking to the patient talking to you, and this is doing all the integration. And for example, if you're also, they are become so smart. If you're talking something non-medical, like today's some sports or some movies or some politics, it discards that information. It is trained to not to record that kind of information. Order entry assistance and prior authorization. This is where most of the physicians now are spending their time. So AI chatbots, AI technology can reduce significantly all this prior authorization support. Care coordination, discharge summary drafting. All you have to do is just talk to the patient and tell the patient what you would like to say. And this records everything. It will give a beautiful discharge summary report. And every one of us has different mastery on English, on the language we speak, and this one will cover you up all that. Clinical rounding assistants, data management. This is another one. Analytics, like you want something says, okay, I want all the blood pressures in the last 1 year to show up as a graph, and it will show up right away. So it manages all the data. Structured data extraction, population insights, it also predicts. And any error detection, if you are doing any error, it will tell right away, okay, doc, you are doing this error. Look at this again. Good. And billing again, we spend a lot of time on this billing, and that will cut down a lot of your time. And it also is very accurate. So you can be comfortable that, like, even when you're done with your billing, it's very hard to know if you have done it right or not right. And you always have that question in your mind, even though you're doing with good faith. So that takes care of it. Staff onboarding. And for example, if you're running a hospital, which floor you need to equip more, which floor you need to equip less, which season you get more patients with what diseases. So it will tell you where to equip yourself more and where to equip less. And telehealth and scalability. In some, chatbots can save clinician time, reduce burnout, improve patient satisfaction, cut costs, and enhance safety. And repetitive jobs, everyone asking, like, what happens to the jobs? If you are in a job where you are doing repetitive and routine, I think those are the first ones to go. If you are in optimizing, then they are the next. If you are in a complex where plastic surgery, any hands-on thing, that will be the last to go. Your secretaries, 5 years from now, you will not have secretaries. You will not have phone receptionists. You will not have MSAs, because robots will be doing most of the work. You will not have repetitive jobs like wheelchairs. You will not have billers. You will not have coders. Again, a doctor trained in AI will replace doctors not trained in AI. Future is scary, but interesting. Thank you all. We'll take questions at the end, and we'll next we will the next doctor is Dr. Manu Sharma, and Manu Sharma. Wait 1 second. Dr. Manu Sharma is Assistant Medical Director of Research and Innovation at the Institute of Harvard Hospital. He holds a faculty appointment at the Yale School of Medicine as Assistant Clinical Professor. He also serves on the chair of Committee of Innovations at the American Psychiatric Association. And he graduated from Mysore Medical College and completed his residency at UT Health Sciences. And he will be speaking on innovations and AI and clinical decision support opportunities and challenges for physicians. Please welcome Dr. Manu Sharma.
Thank you, Dr. Reddy. Yeah, it's wonderful to be here. This is my first AAPI presentation. I've been doing such presentations for the American Psychiatric Association going on for 4 years now. So great to see great attendance, even though we're competing with an India-Pakistan match. So I think this is all good and bodes well for the medical community interested in AI. So As Dr. Reddy, so I work at the Institute of Living at Hartford Hospital, and I also serve as an assistant clinical professor of psychiatry at Yale School of Medicine. Um, like today, we'll talk about like AI and how it can kind of help augment clinical decision support. So I think why does decision support matter, right? So the idea is that we know for a fact that with the advent of electronic health records, the amount of data that is generated by every patient is huge. On an average, like we know, like physicians spend about 2 hours charting in electronic health records as compared to 1 hour of face-to-face patient time. There have been some data that suggests that hospital systems generate up to 50 petabytes of data in electronic health records. So just for some context, a petabyte is about 1,000 terabytes. So like the most common hard drive that you can buy are like 1 or 2 TB hard drives. So it's like 500 to 1,000 of those hard drives. And every patient every year generates about 300 megabytes of data. And if you think about EMRs have been around for the past 2 decades now. So when you see a 20-year-old now, they come with about 20 years worth of data. It's humanly impossible for any clinician or physician to go through all of that data at once. And again, it's like, and it might not be clinically necessary to go through all of that as well. But the idea is that that data might contain interesting clues that might help us personalize those care for the patient that we're seeing in front of us today. So the idea is that with the immense amount of data, we have some very traditional and technologically pretty ancient clinical decision support that exists in current EMRs, and of course, all of this data coming at us. It causes a lot of cognitive overload, and at the end of the day affects the patient-physician relationship, and to some extent can also affect clinical outcomes. So what is clinical decision support, right? So I'll call it CDS for short. I'm pretty sure everybody has gotten those pop-ups working with the electronic health records, which kind of warn you about drug-drug interactions. They might warn you about sepsis risk. They might warn you about something else. And these are based on what are known as rules-based systems. So these are very traditional forms of AI algorithms, which Dr. Agrawal actually spoke eloquently about. So like in short, what is a rules-based system? These are if-then statements. So these are logic statements that are programmed in to the electronic health record. So for example, I'm a psychiatrist, and if I prescribe an antidepressant that is sedating and I prescribe an antipsychotic that is sedating, whenever those two medicines are prescribed together, the rule is that, okay, fine, if you see these two medicines prescribed together, have a pop-up show up that there's a risk of excessive sedation in the patient. Now, normally, within most of our EMRs, we have the choice of either like overlooking them, right? By saying that it's like, hey, this doesn't apply to this patient, or it's an inaccurate warning, or this was tolerated in the patient. So what ends up happening is we get a bunch of these pop-ups happening, right? And in a given day, for every patient interaction, I might have 5 to 6 pop-ups show up. Am I meaningfully using all the information contained in all those clinical decisions like CDS systems? Probably not. They're more of an annoyance most of the time than truly helpful information. For example, like I have taken into consideration a lot of information through the patient history, and when I decide to prescribe these two different agents, there's a possibility that the patient had been already taking those two medications for the past 5 years, but the decision support system does not have any understanding of that context. And because they don't have an understanding of that context, they just give up these pop-ups, which in most cases are not very useful for us and add to the burnout. Now, the idea is that, again, the charting fatigue, EHR fatigue, alert fatigue, is a very important issue in modern practice, right? The idea is that you might have 10 notifications out of which one might be useful, but because 9 were not so useful, it's like the crying wolf scenario where you do not pay attention to the one that you should have paid attention to. So it's extremely important for us to try and improve the way we are coming up with these, or at least training these clinical decision support systems. So again, to summarize, traditional decision support tools, which are available in most modern EHRs, are generally based on rules-based algorithms, which are very primitive compared to the modern algorithms that we have, and are generally not aware of the context in which those alerts are being popped up, and because of lack of awareness of those contexts, in most cases are not useful. So again, like I think this has been already covered, so I'll briefly provide an overview. So when it comes to AI in healthcare, we can use the data that is available, the 300 megabytes of data for each patient for every year, or the 50 petabytes of data in the entire hospital system. We can use those data to train AI models that can help. With predictive models, like predicting things like rehospitalization risks, readmission risks, early warning scores around sepsis and other adverse outcomes, which are very important, where if you're being proactive, we can kind of really reduce adverse outcomes in the long run. We can use natural language processing to extract phenotypes. So I know traditionally we think of phenotypes as the physical representation of a genotype, that is genetic, uh, like a genetic makeup of a person, but we can have EHR-based phenotypes, right? So when we kind of use these models, we can classify patients on certain characteristics using AI algorithms where we have an EHR phenotype. In psychiatry, we have been practicing with high utilizer of services versus a low utilizer of services. That is a patient who shows up in the emergency room like almost every week versus a patient who comes to the emergency room once a year or once every 5 years, right? So there's a different. This is a phenotypical difference between these two patients, and what are some issues that are separating these? And we know for a fact that there are issues beyond traditional medical information that drive these issues. So how can we intervene in this individual who has a phenotype of showing up in the emergency room every week, and how can we kind of provide more resources so that person becomes a person who needs to come to the emergency room once every 5 years, if that.
Manu, your
So we can
presentation
kind
is not there, but I'm not sure if you're talking extempore. I don't see
of,
it. Suresh, do you
oh,
see it?
is my presentation not being? Oh, let me
Can
share
you
it.
share? Sorry,
Sorry about that. I think it's.
but you were speaking so good, so I thought it's all like
Wait,
going
is
to be
it
like
there
that.
now?
Yeah, it's there.
Yeah.
I can see it. The types of AI in healthcare. Yeah.
Oh, perfect. Yeah. All right. So sorry about that. Um, so the idea is that we can have predictive models, we can have LLMs, we can have LLM question answering for the, as well. So in Stanford, under the leadership of Nigam Shah, they have developed these wonderful chatbots where you can ask questions to the EMR, and the chatbot provides very specific answers for the patient. So, for example, the example I used before, right? So a 20-year-old that comes to you today might have 20 years worth of information available in their EHR. Now, it's, as I said, it's humanly impossible for me to go back and kind of review all of that information. But if I'm interested in knowing, it's like, hey, has this person been on medication B ever before? And I can ask that like question to the chatbot, and they can review the EHR of that individual patient and give me an answer. And I can perhaps in a future state even ask, like, how did the patient do on this medication? Because it can extract information from the notes and kind of give us some idea around, okay, fine. It's like, hey, he did not respond well to medicine A, but for the same condition, he was also prescribed medicine B where he did better. So it kind of helps you making clinical decisions and reduces the trial and error part of clinical decision making. And of course, we know that in not in the current state, but hopefully in some future state, we can have AI that can enhance diagnostic accuracy and efficiency. Uh, if the presentation goes away again, please remind me. I'm probably
Sure.
messed up
Okay.
with
No
some
problem.
text. All right, so some real world example. So at the Duke University Health System took up this ambitious project of creating these deep learning models which could predict sepsis risk as the patient shows up in the emergency room. So not even at the point of hospitalization, but once the patient shows up in the emergency room, if they are getting hospitalized, like what is the risk of sepsis there? And it was a system-wide effort and involved a team of computer engineers, frontline clinicians, data scientists, among others, and it did pretty well. It's like, in fact, they were able to kind of so they still the clinical trial is ongoing, but the initial results were pretty good. As Dr. Reddy mentioned, like on all radiology suites, even within Hartford Healthcare, it's like nowadays we get an AI read along with the before even the human read pops up for most imaging studies, and the accuracy levels are pretty good. Uh, in psychiatry, for example, the MIT has developed this model which they call the HIME model, or the holistic AI in medicine, which is able to combine multimodal data. So what is multimodal data? It combines past notes using natural language processing. It can combine medical images from of X-rays, CTs, MRIs. It can take in procedures like endoscopies and other things. It can take tabulated data that is like lab work. It can take pathology reports. So it can combine all of this data together in one algorithm and use that information to come up with predictive insights. So one of our very successful project was using an EKG of a patient along with some demographic factors to predict left ventricular ejection fraction. And the high model performed at an accuracy of over 90% in being able to predict left ventricular ejection fraction just by an EKG. So this is, and of course, this was a pilot study. They have to do much more, much larger studies to actually make it clinically useful. But this is the kind of thing that we can expect to happen in the future. In psychiatry, we kind of struggle with lack of objective markers. So the project that we've been working on in psychiatry with the MIT team is to trying to predict rehospitalization in patients who are being discharged today. So what is the 3-month rehospitalization risk? What is the 6-month rehospitalization risk? And what is a 1-year rehospitalization risk? Now, in psychiatry, we know that we do not have a lot of objective markers. So we can't, just like cardiology, we can't rely on an EKG or an echo. So we largely rely on patient demographics and the notes, the information extracted from the patient notes. And these notes are not only written by doctors, but by other clinicians like social workers, nurses. And we combine the data that we are extracting from all these notes to come up with this predictive insight. It's like, what is the probability that this patient we are discharging today gets rehospitalized in 3 months? And this can easily be transferred to hospitalist medicine or to any other inpatient setting, and there are tons and tons of paper that kind of go into it. But the challenge is, so when it comes to cardiology, the accuracy levels were around 90%. So even with everything and very advanced models and a lot of computational power and like brilliant minds at MIT working on this, we've reached at an accuracy level of around 70%. In being able to predict a 3-month or a 6-month rehospitalization rate based on the information we have in the HR. And I know Dr. Reddy already spoke about AAPI and documentations. So these are some real world examples of how AI can use the data that is available in the electronic medical record and provide very specific insights that help in improve clinical decision making. The benefits are, again, it will reduce information overload. Like as humans, we are good at lots of things. I think the way we recognize patterns and develop clinical intuition over years and years of experience is unmatched at this time, even by advanced AI algorithms. But what AI is good at is consuming large amount of information and coming up with predictive insights and patterns that might not be visible to us as humans. And it can help support diagnostic reasoning, and it can improve efficiency, right? So it's like if I don't need to spend like 25 minutes of my time reviewing a patient's chart to kind of come up with all the information. Either I can chat with the EHR as they're piloting in Stanford, or I can kind of get a summary from the chart, which kind of goes into important points. And in fact, I can even customize what my summary should look like, right? So if my points of interest are only related to psychiatry, maybe metabolic illness, I can kind of train the chatbot or kind of fine tune the chatbot in a way that it can only give me that and specific information from the patient stats that's relevant to me. And of course, I think the most potential is it'll enable personalized medicine, right? Because with the electronic health records, we've been collecting so much data over so many years. We have to find AI would be a very good solution to try and develop meaningful algorithms that can help us personalize treatment to individuals and hopefully improve clinical outcomes as a result of it. Of course, there are lots of issues with it. There's like bias in general, like as Dr. Agarwal eloquently put it, right? Like if you have a bias, you will pass on that bias to your child. So because all EHR data is actually like is reflective of the bias that humans have, any model that is trained on it would actually like perpetuate that bias. There was one excellent study that came out of Stanford's group led by Ethan Goh and his colleagues, where they kind of gave access to a general chatbot like ChatGPT to clinicians as they were making clinical decisions in a synthetic setting where like they were interacting with clinical case vignettes, so not in clinical practice. But what it realized was with the help of chatbots, uh, any biases they might have had, it's like, so they kind of changed the demographics of the patient. So they converted the patient from being Caucasian to African American to Hispanic, and they kind of tried to and they compared the outputs of the humans with the outputs of the chatbots. Surprisingly, the chatbots were not did not kind of were not affected by the changes in demographics as much as the humans were. And the best part was when we combine AI augmented humans. That means when the humans had access to the outputs from the chatbots, their decision making also became less biased. So in a way, there's a potential that we can of course, we can kind of perpetuate the bias, but if we design these systems in an intelligent manner, it can kind of help us or prevent us from perpetuating some of the biases that exist subconsciously in all of us, right? And of course, there are issues with black box. So these are all black box algorithms. We don't know how these arrive at the decision state too. So we can't explain the decision to our patient as to why we are doing something that we're doing. So, for example, when I say that a patient of mine says that there is an 80% risk at this time of this patient being rehospitalized in the next 3 months, I don't. Honestly, the algorithm doesn't tell me why that is or what information it used to arrive at that conclusion. So I can't explain it to my bosses in the hospital. I can't explain it to the patient. So I think that's a big issue. And explainable AI will be a big thing moving forward. There are again, it's like there are modern LLMs have a chain of thought which you can look at, but I'm not quite sure if it truly represents the chain of thought which the LLM takes, and it's still quite a mystery, and workflow mismatch, right? So I think we know for a fact that electronic health records are one of the leading causes of burnout among physicians. And if we do not pay close attention to how we're designing these AI workflows, we might be in for a similar issue with these as well, where we might just have a lot of alert fatigue, we might have a lot of irrelevant information with us, and it will just be another reason for burning out, right? Rather than actually paying attention to the patient. Now, as I said before, safety, ethics, and regulation will play a big role. Regulation will always follow innovation because innovation moves at a much faster pace as compared to regulation. FDA, thankfully, has come up with a new adaptive framework for AI and ML-based softwares, even in medical equipment that will use AI and ML. And they've come up with very specific frameworks which will ask the companies to be very clear about what kind of data that model was trained on, what was the scale of the data, was it representative or not, did the patients who will be using it represented in the data that the algorithm was trained in, right? So it's like if I want the algorithm to help me in psychiatric clinical decision making, they can't be trained on a general medical data set, right? It needs to be trained on a data set comprised of psychiatric patients. What kind of accuracy was arrived at? How was that arrived at? And then what is were there any steps taken to reduce the bias? Were there any steps taken to kind of detect accuracy? Was it done in real clinical work setting, or versus it was done on synthetic data where like you created all these clinical vignettes and or something else to help improve its functioning of the algorithm. So it has come up with a very important framework, and there's still work ongoing. But it's very good news because FDA prior to this did not have clear guidelines around AI ML based software. And the best part is, right, because so in tradition, like if you think about a medicine that got FDA approved, right, the chemical formulation of the medicine stayed the same. So if I'm prescribing sertraline to a patient, the chemical formulation of sertraline stays the same. But the AI algorithms can actually update themselves as time progresses. So they also have coming up with mechanisms where they will also test how these models will get updated, and the company will have to provide at the time of submission how they're going to update it, what will be the stages of updates, and how they'll apply that, and they will have to give that information before they get any FDA approval. And of course, liability remains unclear, and we have a presentation by Dr. Khurana later on, like who's liable. So if the chatbot or the clinical decision support system tells me that it's like, hey, this patient will do best with medicine A, and for some reason I choose to ignore that recommendation and a bad outcome happens, will I be liable? Or if the AI gives me a fault for a wrong recommendation, I choose to follow the recommendation, will I be held reliable? Will AI be held reliable? Will the institution be held reliable? There are lots of legal questions around this which will need to be addressed moving forward. And of course, there's a big risk of equity. Like my thought process is that we might end up having a tiered system where if you're poor and do not have insurance, you might be treated by AI, and human physicians who you, as Dr. Reddy said, who know how to work with AI, might come at a premium. So that remains to be seen, but I think there'll be a big equity risk as in the implementation of this. So again, the idea is going from reactive care to proactive care and integration of multiple modal data. So it's not just unidimensional, if-then rules-based AI systems. These are very strong systems that are trained on multimodal data, which include lots of information in the electronic medical record, notes, imaging, genomic data, speech data, among other things. And of course, patient-facing tools, right? So the patient can input their own data, right? There's something called as digital phenotyping, where we are able to collect data from patient wearables or the patient phone and come up with clinical insights based off of that. They can input their blood sugar levels every day, and it can go into the electronic health record. They can update their blood pressure recordings every day, or they can kind of their variable can be directly connected to the EHR and might give us insights into how the patient is doing outside the hospital system. So we can take more proactive actions rather than being reactive and waiting for the patient to get sick first. So role of physician will be extremely important. It's called human in the loop approach, where humans will always have the final say. So again, there's a famous rule in informatics that says it should be human plus the computer system should perform better than the human alone or the computer system alone. So we will have we'll have augmented intelligence using the AI algorithms and CDS systems, but it'll be very important for physicians all over. So I tell my medical students, I tell my residents that AI will be here, and if we are not playing an active role in how that gets implemented, we might end up like the situation will be not very different from what happened to EHR, where we will have competing forces that will take over, and the physician, the patients might be left behind in the way they're implemented. So I think it's up to us as caretakers of our patients to educate ourselves and educate them and play a very play a role which at the forefront of implementation of these AI tools in clinical practice. So the key takeaways is AI will enhance and not replace clinical judgment. It can help us with efficiency, personalization, and early detection. Of course, there are risks of bias, black box nature of these algorithms and workflow related issues. But the most important point is physician leadership is essential. All of us are leaders for our patients, for our clinical teams. And when we see AI algorithms being implemented, we need to ask the right questions. We need to know what questions we need to ask. We need to learn about these things so that we are protecting the patients and the patient-physician relationship as we move forward. And we kind of, the first principle of do no harm is upheld. So those are the key takeaways. Thank you, and I'll stay back for questions later on. These are the references if anybody's interested in, and then, of course, thank you so much.
Thank you very much, Dr. Manu Sharma. Now I would like to introduce Dr. Ritu Khurana, MD, MLS, FACR, FACP, rheumatologist, health policy advocate. Ritu Khurana is a board-certified rheumatologist and internist at Geisinger Medical Center in Scranton, Pennsylvania. She is the Chief Legal Officer for Mloxy LLC, which is developing next-generation technologies for medicine. She holds a master's in legal studies from Thomas Klein School of Law and has completed a business leadership program at the Lebow College of Business in Philadelphia. Her interdisciplinary background informs her special interest in healthcare privacy and ethical implications of emerging technologies. Dr. Khurana is the author of the book Privacy in the Age of Artificial Intelligence. Please welcome Dr. Khurana. She'll be speaking on ethical and legal issues in AI.
Thank you so much, Dr. Reddy. And good afternoon, everyone, on this great day. They are moving by themselves.
You were there. You were there. You just went away.
The slides are moving by themselves.
Yeah, it's moving now.
Yeah, we can see the slides,
It's on the
Dr.
third slide
Kurana.
now. Transparency. Yeah.
Thank you. Sorry about that. And thank you, Dr. Reddy, for introducing me. So to end this all, thank you everyone for the wonderful presentations. And I know we talked a lot about AI and how we are implementing that. I do want to talk about some legal and ethical issues in AI that we face every day or in the future. In the next couple of years, we will definitely see more legal issues associated with that. So I wanted to talk about that. So here we go. Introduction. So although AI is very revolutionizing in healthcare, we know that, but like Dr. Reddy and Dr. Sharma said about diagnostics and treatment options and operational efficiency, but we do have profound ethical questions using AI, particularly around privacy, autonomy, and accountability. At the heart of these concerns is the big, huge patient data, like Dr. Sharma was telling about. Thousands of terabytes of data are collected every day in healthcare symptoms. AI thrives on these large databases, often derived from EHRs, imaging, genomics, and mostly IOMTs or wearable devices that we see. Um, while this data fuels innovation, it also introduces significant privacy risks, raising concerns about informed consent and data ownership. Informed consent and bias are the two big things in ethics and legal privacy issues in AI today. Ethically, AI must uphold the core principles of beneficence, non-maleficence. We are all physicians, we know what that means, justice and respect for persons' data. In 2025, the conversation around AI ethics in healthcare is no longer theoretical. It is urgent, it is practical, and we should definitely talk about ethics. So these are the four big ethical principles in healthcare using AI. Beneficence, you all know, is do everything you can to help your patients. Non-malfeasance, do no harm, respect their data, and justice for all patients that we see. So the four big ethical challenges, primary challenges that we see is informed consent to use. We all use it in our EMRs today. If we are using AI to record anything from them or using it to do our dictations or collecting data, then safety and transparency, fairness and biases, and we'll go over those. And then privacy is the big thing. And that's my book that Dr. Reddy mentioned. And these are the 5 legal challenges. So those are the 4 big ethical challenges, and the legal challenges with AI are safety and effectiveness, liability, data protection and privacy, cybersecurity, and IP law. We'll talk about that. In the word of OpenAI today, we definitely have to think about IP law. Safety. It is the biggest challenge in healthcare. I will start with examples because I think it'll make it more interesting and easier to understand. One well-publicized example is the IBM Watson for oncology data that was used. It uses AI algorithms to assess information from patients' medical records and help physicians explore cancer treatment options for these patients. It was recently come under criticism by reportedly giving unsafe and incorrect recommendations for cancer treatments. And the main problem with that data was the training of the data that was done. It was the training of the Watson data in oncology. Instead of using real patient data, the software was trained with few synthetic cancer patients or cases by a few group of doctors, 5 doctors at Memorial Sloan Kettering, how they were treating lung cancer or how they were treating breast cancer, not use real patients, put all that data into AI, and they were using those algorithms to treat every patient. Now, 12 months later, they figured out that most of the pathways that the software was giving to treat those patients were actually not real life examples. And that has really put a negative light on this AI thing. And it has also shows that it is very important that AI information is safe and effective, and where you put that data from. So whatever you put in is going to come out. AI is not human. In 2016, another example, digital mammography, the DREAM challenge, was done where several networks of computers were connected. The goal was to establish an AI-based algorithm by viewing 640,000 digital mammograms. The best which was achieved with the specificity of 0.81, sensitivity of 0.8, which is roughly approximated to the bottom 10% of the radiologists, how they read MRIs. So in conclusion, AI does have potential, but it's unlikely that AI will ever replace doctors. There is good data in dermatology and radiology, better data now today regarding how we input data, but this is something that I wanted to highlight when we were using this initially. AI did not perform as well as radiologists would, and it approximated to the bottom 10% of the radiologists. Then there's the issue of transparency. The AI developers should be sufficiently transparent about the data used with any shortcomings of the software that they use. This is called data bias. We should learn from our lessons from examples like Watson for Oncology, where IBM Watson actually kept that unsafe and incorrect recommendations secret for over a year just to experiment with that. So transparency creates trust among stakeholders, particularly clinicians and patients, which is the key to successful implementation of AI today. The next big question is bias, and there's different kinds of biases, but we'll talk about bias in artificial intelligence today, mostly based in healthcare. AI bias, also referred as machine learning bias or algorithmic bias, that it does reflect and perpetuate human biases. So whatever our biases is fed into the computer, and that's what comes out. So bias can be found in initial training data, the algorithms that we produce, or the predictions of the algorithms that are inferred by those physicians. So AI bears a risk for biases and thus discrimination in healthcare delivery. We'll go a little bit more over bias today and fairness. AI does has the capability to improve and globalize healthcare and bring it to even remote areas. We all know about telemedicine, and also telemedicine in remote areas, but also in the US when we had that epidemic in 2020. Any machine learning systems or human trained algorithms will only be as trustworthy, effective, or fair as the data it is trained with. So several real world examples actually have exhibited biases that can result in injustice regarding ethnic origins or skin color or gender biases that we see. Face recognition algorithms boast high classification accuracy, but these outcomes are not universal. And then there's this landmark study about gender shades in healthcare in 2018, where an intersectional approach was applied to appraise 3 gender classification algorithms. And all these algorithms actually performed the worst on darker skinned females with error rates up to 34% compared to lighter skinned males. So you can think, if you are inputting data based on a certain gender or ethnic group, then it is not inferred, or it should not be inferred to every patient in the future that you treat. In the healthcare sector, where the phenotypes are sometimes genotype-related information, biased AI could lead to false diagnosis and render ineffective treatments. For example, the AI clinical decision support software helps physicians to find the best treatment for patients with skin cancer. However, this algorithm was predominantly trained on Caucasian patients. So when you allow this AI software to make clinical decisions for skin cancer patients, it actually gave very inaccurate recommendations for subpopulations like African American patients or Hispanic patients, where the training data was basically trained on Caucasian patients. Racism in healthcare allocation, again, causes a bias in delivery of healthcare today. In 2022, a team of University of California, Berkeley discovered a problem with the AI that was being used to allocate care to 200 million patients in the US, which resulted in Black patients receiving a lower standard of care. Across the board, the Black patients were assigned lower risk scores than white patients, despite the fact that the Black patients were also statistically more likely to have comorbid conditions. So if you all use EMR, especially in Epic and both in Cerner, you know, in our patient charts, on the right-hand side, we have a risk score, which gives us their hospitalization risk or having a future risk of having a stroke based on their other personal comorbid conditions like hypertension or diabetes. So this is the data that was input, and it actually was found that African American patients were assigned much lower risk scores than white population in that data. This in turn meant that Black patients were less likely to be able to access the necessary standard of care and also likely to experience adverse effects. The system stemmed from the fact that the patient was allocating risk values using the predicted cost of healthcare as the determining variable in this data set at UC Berkeley. And because Black patients were often less able to pay or was perceived as less able to pay for the higher standard of care, so they were given a lower risk score. When they made out this discovery, actually, UC Berkeley team worked with the company responsible for developing this tool and how to assign these risk scores and reassign, thereby reducing the bias by 84% in that data set. So early recognition is actually important when you are working with these companies. Another issue with data privacy, in July 2017, the UK Information Commissioner's Office ruled that the Royal Free NHS Foundation was in breach of the UK Data Protection in 1998 Act when it provided personal data of 1.6 million patients to Google DeepMind. This data sharing happened for clinical safety testing for Streams, an app that aimed to help with the diagnosis and detection of acute kidney injury in these patients. However, the patients were not properly informed about the processing of their data as part of the test. So here's where the informed consent wasn't done correctly. And then the information commissioner correctly pointed out that the price of innovation does not need to be the erosion of fundamental privacy rights. In this particular study, they did redact the personal information for those patients, but they did not do it correctly. So via triangulation with Google and the EHRs, they were actually able to identify each patient personally and who that data belonged to. So data privacy also requires very safe storage and appropriate deletion. And the principle traditionally governing data storage has been that it should be kept for no longer than necessary, which is very subjective right now, how long that is for the purpose of which it was collected. Then there's the question about privacy and ownership. Who does that data belong to? Current legal system of ownership and privacy of EHR mixes clarity and confusion. In the era of paper medical records, there was a seminal case about McNeary v. McDonald, which set forth clear law. The healthcare provider that produced a medical record owned the physical record itself, and the patient had a right to access it. The problem of data triangulation also recently has been featured in another lawsuit, more than what I just talked about, in the Dinerstein v. Google and the Project Nightingale by Google and Accenture, where there was recent case studies showing patient privacy concerns in the context of the data sharing and the use of AI. Some AI health apps also raise new issues, such as those that share patient data, not only with the doctor, but also with family members and friends, especially that we use Dexcoms today or continuous blood pressure monitoring in these patients. And another sensitive issue is whether or not, if so, under what circumstances, patients have the right to withdraw their data. So there is this legal law in the EU. We do not have a federal law in US yet, but we do have individual states that follow this. But there is federal laws like the California state law or the Utah privacy law or the Virginia privacy law. But in EU, they have a federal law where patients have a right to consent how much data they want to give out and what they want to not give out. And then even after they have consented, do they have a right to withdraw that data at any point? And that's true in the EU law, which is the GDPR or Global Data Privatization Regulation law. Can patients request the deletion of the data after it has already been analyzed in aggregated form? Like I said, there is an EU law, there is individual state laws in the US, but no federal law for that right now. So that's a big issue in AI right now, which we might see in the near future coming up with a new federal law where patients should have more rights of what they want to do with their data. We all know about HIPAA. It has significant gaps when it comes to today's healthcare environment. It does not apply to non-health information like purchase of a pregnancy test on Amazon. A 16-year-old girl can do that, but that's not regulated. The problem of data triangulation has also been recently featured in another lawsuit, like I said, where medical records were shared and there was enough information that enabled Google to potentially re-identify those patients, given all that its other data was on hand, although their names were redacted from that data. And then there's the question of liability. Like the new AI-based technologies also raise big challenges for this. It is crucial to create an optimal liability design that figures out responsibility. As an example, when a case of malpractice arises, where AI is involved, especially in radiology or pathology, it is currently very unclear what extent each involved party bears responsibly. Is it the patient's physician, the institution at which the AI was applied, the broader healthcare system, or the AI technology developer who developed that EM software to be applied in that EHR? So that is a big question about malpractice liability right now with using AI, which we should all be very careful about. Cybersecurity is another important issue that we need to consider with the increase in use of AI in healthcare. In the future, much of the healthcare-related services, processes, and products will operate within the Internet of Things or Internet of Medical Things, like we say. Unfortunately, much of the underlying infrastructure is vulnerable to both cyber and physical threats. There was in where I am, it is a small suburban area in Northeast Pennsylvania. There was a big lawsuit involving one of the big hospital systems where patient data was compromised. And 2 years later, actually, all those patients did get large amounts of money, but their data was out there everywhere because of a cybersecurity threat. Targets in the health sector may include hospital servers, diagnostic tools, wearables, wireless smart pills, especially when they use GI smart pills today and medical devices. And all these can be infected with software viruses or Trojan horses, like we call in the AI word, or worms that risk patient privacy and health. Yet another concern that relates is the doctor-patient relationship is, will AI diminish the role of doctors? I know Dr. Reddy went through that, but will computers be the ones to make predictions, diagnosis, and treatment suggestions so that doctors simply implement what the computers indicate? And then how do our patients feel about the computers having a greater say than their doctor about their medical decision making? This is a study from MIT, which was cited in a Fortune article that said the human body hungers for companionship in much the way we hunger for food. This means the human interaction is especially important, especially in light of all the technology we are surrounded with and consume on a daily basis. I am sure AI is not replacing humans today. We all, though, need to be aware of what's out there, one, to make our lives easier and our patients' life easier, but also to have these guardrails around AI to protect the privacy and for our patients and liability for us. In order for AI to make a positive, sustainable impact on customer service, a healthy dose of personal human touch is needed, where computers actually can never take over physicians. These are some of the newer things that are going on, trends and strategies in US in 2020. The White House published a draft guidance for the regulation of AI applications, where they said the first thing should be public trust in AI is the first principle to develop a new software. The second is public participation. Then there's scientific integrity and information quality, risk assessment and management, the benefits and the cost, do they outweigh what we are already doing? Fairness and non-discrimination, disclosure and transparency, safety and security, and then interagency coordination to actually apply this in real world. And the regulatory landscape in 2025, we have a joint commission and coalition of health AI, which has released a national guidance for responsible AI use. This time is not enough to go into that, but I would encourage everybody to go online and read about this. As an Indian, I remember this, please remember this as CHAI, CHAI. But that's the document that's out there. Then there is the URAC or URAC launched its first AI accreditation program for healthcare, and the ITU WHO focus group, which developed global standards for ethical AI deployment, especially in healthcare. And ethical frameworks where there should be emphasis on human-centered AI, augmenting, not replacing clinicians. The legal frameworks must address consent, like I said, accountability and equity, and collaboration between developers, especially clinicians and ethicists, is very essential when we develop these AI frameworks in our practice. In summary, there is ongoing refinement of ethical guidelines, especially by the federal government right now. Greater patient involvement is necessary in AI governance, and expansion of AI literacy among healthcare professionals is of utmost importance that we use it with guardrails and responsibly. Thank you, everyone.
Thank you, Dr. Khurana. We'll try to take some questions from the audience. Let me see, what are the questions?
So Suresh, I wrote down if you want to go with that.
Okay, you go ahead and start. Yeah.
You take, and then you can take it who should wants to, okay?
Okay.
So I think the question is that how reliable and accurate ChatGPT is when we ask the diagnosis or management after feeding history and physical finding. And in this, Dr. Gupta's belief, he finds it very correct most of the time. When it is not, gives us a differential diagnosis to any.
I think just for a small correction, for the legal issues, we cannot use the commercial name. We'll just call everything
sure.
chatbots.
Yeah.
Yeah, go ahead.
So any kind of AI chatbots that you found it
I can answer that.
Yeah.
If you want, I can give you a general answer.
Sure.
These things have saturated out at about 90% accuracy. Now, it all depends. It's not an easy answer to give for healthcare or for financial services, because a lot of healthcare data is numbers related, especially for patients. Blood pressure is a number and so on. And when it comes to numbers related data, by and large, GPTs, LLMs falter because they're mainly trained on text. Nevertheless, they're reasonably good. And I think an important point to remember is to use, one of the speakers talked about it, to use it as a decision support system, not as a decision-making system. As I gave the example of two lawyers who got caught because they believed a lot in GPT and it messed up. I think you have to, as medical doctors, you have to look at what is coming out of a GPT or an LLM, and then make your choice as to what is right and what is wrong.
Okay, great.
I can take a stab as well. So there's been some systematic research that has been done by the ARISE group out of Stanford. Dr. Ethan Go, it kind of leads some of that research. And I just posted a link to his publication page, which kind of delves, and they looked at multiple aspects of how kind of like humans, like human doctors plus like advanced GPTs and the LLMs of the world, LLMs alone and humans alone do on like when data is inputted into them. So they've done some like very preliminary but very excellent work in this, and I would recommend like people go to his page and go through his publications.
So just to expand this question, Manu, what would you be still careful, even though you cannot rely on this all the
100%.
time? How can you be vigilant? What can you do?
I would say, as a rule of
You
thumb,
should treat
trust
them like the
yourself.
residents who comes and tells you the diagnosis.
I would treat them as like no,
Your
I
fellows.
wouldn't use the, I wouldn't. I tell med students, so med students residents who come to me, I tell them use it as a learning tool where you ask it to kind of create clinical vignettes or something else to help you practice questions. I wouldn't recommend personally using chatbots for clinical decision support at this time. Although these models are very advanced, again, there are lots of legal, compliance, and ethical issues associated with using chatbots in day-to-day clinical practice that remain unanswered. And I wouldn't trust most answers at this time. Of course, you can consult it. Like use ChatGPT as you would use Google at this time. It's like they're all tools. Of course, ChatGPT is much more advanced than Google, but I would say there are concerns apart from accuracy, which we should be very worried about. And not use them at this time for clinical decision support, especially like Dr. Khurana can speak to this. So using the IP address where it was inputted from and other things, even if you don't put in PHI, there are ways in which we can backtrack that information and identify who that information belongs to. So I just feel like there's lots of issues there, and I would be very careful. I tell my residents not to use it as now. Use it as an educational tool, learn about things. You have 4 years of med school training and years of residency training.
Mm-hmm.
And you can kind of ask questions in terms of clarifying concepts if you want, but I would never enter patient data, even if it's no PHI into chatbots.
Suresh, any comments?
Yeah, actually, I would even go 100% or 115% sensitive. Sometimes it's more accurate than especially I can speak for radiology. It's more accurate than radiology in some reports. But if they make a mistake, they make horrible mistakes. Like, because I showed you a chest X-ray picture and how the human reads the chest X-ray and how the computer reads. And sometimes it may be totally off when none of the residents or fellows or any of the trainees will be that off. It can be just say like it's a cancer of brain. It can read as like something in the pelvis. So it's kind of totally, when it's off, it will be totally off. So you have to be careful at this time. I think it may be a time when they will totally, I can believe that they will totally replace human brains. In the reason because in your whole lifetime, how many books can you read? Like 100 books, like medical books. How many papers can you read? Like 1,000 papers. But this one can read all the books, all the papers, everything available on internet. So it knows a lot more information. We are not at the place where the computation and compilation is not that perfect, but one that's become perfect. I think it will be very hard to play. It's like a gambling with a slot machine in thing. They are programmed such there to win, and they will win us. So yeah, we have to be. I think we are not there yet, but I think there'll be a time where it can do better job than us. But again, the only advantage we have is we have DNA. DNA is all the information stored for billions and billions of years. It's inside us, which we don't know how they express. Like you don't know how, there is no script, how you react to one question. So it's a very variable. So that is advantage we still have. We still have billions and billions of years of information stored on us, which we don't even know.
But Dr.
So, yes.
Unfortunately, from a computer science, and I'll only talk from a computer science perspective, these LLMs and GPTs are stuck. It's not that in 5 years, the hallucination that you were talking about, that it talked about cancer in the brain when it was completely and totally wrong. Call it a hallucination, call it a delusion. we do not know how to solve this problem. These things are unexplainable, non-interpretable, and unless we have another technology like reinforcement learning or something else in the next 5 to 10 years, this will continue. In fact, in computer science, it is well accepted right now that if you can solve the hallucination problem, you would get the Alan Turing Award, which is like the Field Medal of Math or Nobel Prize in chemistry or physics. So I don't think that's going to happen in the next 5 to 10 years.
Yeah, I agree with you, Dr. Agarwal. But I think just for the sake of audience, hallucination is a term used in AI, where AI has one bad habit. Like if I ask any chatbot or anything, especially in radiology, I ask a question, it will never say no unless you train it to say no. It will come up with some answer. It will come. Hallucination is one thing where it just comes up with some kind of excuse and comes up with some strange answer. So if you look at, we have looked at Dr. Agarwal's history in the last 75 years. If you look at the table, the timeline, in the last 50 years, even though artificial intelligence was termed in 1950s, there was a movie by Steven Spielberg about artificial intelligence in early 2000s. It did not grow that fast until the last 2-3 years. The amount of medicine, the amount of AI change in the last 3-4 years is 100 times more than what happened in the last 70 years. You agree, Dr. Agarwal?
Yeah, but I agree. And yet,
so if you keep going at the same rate,
yeah, but
this information is changing on a daily basis, hourly basis. So
where I disagree is the obstacles, right? There are
yes,
some fundamental problems. Yes.
I agree.
So 2018 is when transformers and LLMs came about. So, I mean, before 2018, it's not worth discussing IBM Watson in 2016 because it was a different ballgame. So I agree that in 8 years, 2018 to now, a lot has changed. But the hallucination part has remained constant. And I think it is important for all the medical practitioners to remember the whole notion that you pointed out about that particular radiology case, that it went wrong and went wrong completely, which is an example of hallucination. And that I do not know. In fact, we do not know in computer science how to solve that problem. And I think that needs to be kept in mind, whether we use it as a clinical decision support system, as a training system, or whatever. That's a very fundamental issue.
Okay, Dr. Sharma.
Yes.
Yeah, so I think, so the way I think about LLMs is like, if you think about how humans train ourselves to become specialists, we have 4 years of general medical training, then we go into specialized training. As we go into specialized training, some of our general training there's an attrition to it. I would say any AI algorithm, for that matter of fact, general models will have their limitations, and then specialized models will need to be eventually developed, right? So when it comes to medicine-specific LLMs, there are some very good examples out there that have been trained on open source LLMs, like Gatortron, that was developed by University of Florida, and then we are actually working on a psychiatry-specific LLM, which we are using like the general large language models, and then training it on very specific psychiatric data to try and see if it is better at answering psychiatry-related questions. Even with that, I think the accuracy levels will have a ceiling, and that's where the human judgment will come in. And it won't be a question around technology. It will be, I think, the answer will be shaped through policy and regulation as to how we are allowed to interpret this. And I think it will be as the AI will become multimodal, the answer to this will be multimodal as well, because it will depend on just pure clinical practice, along with how regulations shape those clinical practice, what are the hospital policies. So it'll be different agencies coming in and telling us how we can and cannot use this. It would not just depend on accuracy, is what my sense is.
Okay, I think you guys have great knowledge, but keep your answer short. Next question is how to get certification in AI in medicine, please. And somebody says there is also a WhatsApp group, Doctor's Diary, and there is a link there in the thing. So, and I think
there are several
organizations are also, our specialty organizations have their own certification, I believe. But go ahead, Suresh.
I think there are several agencies that are giving certification. Some are trying to make big bucks, quick bucks, and some are genuine. I think you should go with a good organization. And I think Dr. Alok Agarwal suggested that why don't we, AAPI has its own certification. If Tarak Bhai and Amit decide, I think we can come up with a good program. Actually, if they both agree, I think we'll maybe having another session, symposium, a longer one, maybe in few months from now. I'm trying to bring some faculty from Harvard and Stanford. Actually, Manu Sharma just mentioned about Nigam Shah, and he's one of our pioneers in AI. And I talked to him, and he's willing to come to API and speak to us. I think we'll bring some good faculty, and hopefully we'll have a certification. And let's work on that, Tarak, Dr. Tarak,
Okay,
and
that is a good idea. It's a good idea.
I think a certification with API would be very useful. The reasons I particularly bring out API is particularly because of some of the issues, privacy issues that US has, but India does not have. I, for one, people don't realize I'm a very strong believer that India and China will do so much better in adopting AI in various places, not only what we are talking about, but AI with respect to Internet of Things, with respect to hospital beds, and so on and so forth, because the privacy issues and others are so much fewer in India. And therefore, these countries, just like what India did, it basically skipped one generation in financial technology, in banking. I think that's going to happen in the next 10 years in India, because a lot of these things which can be implemented here will be stopped because of HIPAA and all the privacy issues. And Europe is much worse. I mean, I think one of the speakers mentioned about GDPR and all that. India, on the other hand, and people don't realize, and because I'm in computer science and in AI, I see it all the time. India is doing so much more in AI, in healthcare than US is, that sometimes it's mind-boggling. So I think giving a course which is less to do with math, less to do with algorithms, more to do, just like my book, I'm not trying to advertise it, more to do with, hey, what is it about? What can it do? What are its pitfalls? And what are the use cases where you can use it and how to use it? I think it could be a good, a nice course that, in my view, API should create. Could be about a 15, 16-hour total course that a person can take via video, and you can have some question answering system and then give a certificate. But you would do the whole API community, and probably in general, the medical community, a very good, because there is a lot of misinformation in the whole.
We'd like to hear maybe a couple of things from Dr. Khurana. How did you become so knowledgeable in this area? And then followed by Manu, I know API is doing something and you are part of it too. So keep your answer very short. Go ahead.
Sure.
So many questions here.
So like Dr. Reddy mentioned, I've been a rheumatologist since 2004. And I was practicing, and my daughter went to college, and my husband was always, traveling. So I decided actually to go to law school. So I went to law school in 2018 to 2021. And in 2018 is when the GDPR privacy EU law came out. So that became my thesis in law school. And then I started looking into why we should look into this and what's happening in the US equivalent of that, GDPR in EU. So that's what, not advertising again, but that's what my book is about, how we should derive it and what we have changed in the last 7 years and where US is going into that. So that was my thing to get into this, privacy and ethics.
Great.
Thank you. So actually, there is another question by Dr. Kakani. It's a very valid question. This is especially for the artists and the book writers, everybody here. Like art, especially for the book, I have a very friend. She has spent last 3 years trying to write a book, and she put heart and soul into that. And it is so. How can we know if it is AI written? AI can definitely write better than us. Like if you ask AI to write a poem about yourself, and I ask AI to write a 2-page synopsis about me, and it wrote so well, I could never write so well about me. So writing about this book, so especially in US, the US is behind in AI as compared to India and China for a good reason. The reason because the regulations are so well maintained here. So if somebody is going to a publisher and asking to submit a book, the printed material, the book the publisher is saying that you should write there that this is not AI written and this is not AI, because it's easy to find out if it is AI written or not. So books which have that statement, that disclosure saying that AI was not involved in writing in this book is selling more than when you say AI is involved. So you have to make that disclosure in the book, and all the publishers are being regulated to put that. It's like a cigarette. Cigarette is injurious health. Same thing. This book is written by assistance of AI. This book is not, AI is not used in writing of this book. So those statements are going on the book, and that can really help. Same thing with painting and arts. Some people can paint so well, and AI can do a better job, but you have to separate both of them. So especially for the artists, I think it's going to become difficult and difficult.
Okay.
Thank you, Dr.
Suresh, you want to take
for
the
your
question from
question.
here? I mean, if you want to go ahead and take it over.
Yeah. Where are the questions? I can't
Okay,
see
I think
them.
I have some
Where
here
did you
that
write?
I put it in a Word file, but I can go with that. Something question on ageism. Is there a thing, governor's law, any kind of law against the old people? And I think there's some law probably for that too, for the race, aging, etc. Ritu can answer that. Dr.
Can
Khurana?
somebody type it again? Oh, can differentiate.
Okay. I can type all the questions I have, Suresh, and put it in
Yeah.
in
Yes,
a minute
copy and paste it.
while Dr. Khurana answers this question.
Dr. Tharak, can you please say that question again one more time?
So the question is, are there any kind of steps taken for particular groups? Like I mean, Dr. Lathia is asking for aging, but I'm asking also for other discriminations and bias. And I think you already mentioned some of those things that may be covering it.
So, like I said, yeah, so bias and consent are the two big things. If you can get around that, it is a very legal thing. If there groups around that, no, but each hospital system has their own legal system, and we just had a 1-day whole webinar about legal and AI ethics and stuff. Like, I'll give you an example. There's no name to it, but there is an app that we use because dermatology is so hard to get into in our hospital system, that we have an app where if a patient comes in with a rash, especially being a rheumatologist, we can plug that and put a little bit patient history, which is within Epic, not using a PHI, but again, that is, it'll come with 5 differentials. So it is giving you ideas, but we are not using that without using our brains. I always say, I mean, AI is there to assist us, but it can never replace physicians' brains. We constantly learn too, and AI is either learning or not learning. But can we compare our training? So sorry if we have any, but can we compare our training and how we learned to a nurse practitioner plus AI? And the real answer, easy answer is yes, but I don't think that's ever going to be true. So it's just a personal thing. Keep reading, keep doing that, and you will learn how to do a bias. Is there any legal groups out there that you can join? No. But some of the AI courses do just talk about bias and privacy and ethics.
Okay, thank you so much. Um, I think I can ask a couple of questions. Are there AI consultants for small practices? We cannot discuss commercial names here. So I think if you can email us, we can answer you later. And what is ambient? I think I'm trying to avoid all the commercial things. So I think we have finished the 2-hour session. We'll close the CME so that we can ask some personal. Please hang out for a few more minutes. I will show you how to personalize the chat GPTs on your phones. If you wait for 5 minutes, we'll close the CME session. Tarak Bhai, if you can close the CME part, then we'll have a regular discussion.
Okay. Just again, the disclaimer that Dr. Reddy has put it out, that this course is by AAPI, but it's for education purpose, and you use your discrimination in clinical knowledge. The speaker's views are being expressed here in the CME, and please advise, your legal team if there is any kind of particular kind of questions that are mentioned that you would address. At this point, I think we are closing the CME. I really would like to appreciate everybody who took time. I did not realize that you all are almost like a book author in these aspects, and to that level, you've done deep research. I know Manu from APA is always there at the APA, and that's another idea we have, is to bring the innovation series. Am I right, Suresh?
Yes,
we're going to have the young people coming in and throwing a pitch, so we can kind of invest in that too down the road. But again, I appreciate Dr. Reddy, first of all, to create this series and work on it very hard. Dr. Agarwal, always ready to work and help us out in this. His lectures, even before to AAPI, have been still thought about by people. And Dr. Khurana, even though she traveled from India, she came last Sunday only and did all the paperwork. And such a knowledgeable team, so I appreciate it. I'm closing the CME at this point. Amit, if there, maybe say something, but I think he's in the procedure area. So if he comes back, we'll let him give a stage. But thank you, guys. You can
thank you,
hang around for
sir.
Suresh's
Yeah, so just
personal
to
instruction thing here, which I'm interested.
Yeah, so I'm trying to convert the disclosure. The American Association of Physicians of Indian origin, AAPI, is a 501c3 non-profit organization. This meeting is intended solely for informational purposes. AAPI does not endorse any information discussed here. All views and comments expressed during this event are solely of this invited guests and do not represent the views or official position of AAPI. CME certificates will be issued to AAPI members only. Thank you. That's a discuss. So officially the CME session is closed, and we can discuss some commercial things. And I have I'm sure I use almost at least 6-7 chat bots, but I'm sure most of you, because 80% of the market is chat GPT, will give like just a 15-30-second break, so that it will be a different session and we'll talk.
Thank you so much for inviting Dr. Costa, Dr. Reddy. I'll log off. Thank you so much.
Sure. Thank you, Manu. I hope to see you again.
Absolutely. India's batting really well, so I think I have to go.
Is it? Oh, great. I didn't look at the score. Thank you.
Good. So it will only take 5 minutes. So what we'll do is, if you let me get my, so please open up your chat GPTs on your iPhone.
iPhone, okay. Is it okay, Suresh? I don't have upgraded version. I'm not still ready to pay $20.
I think should be okay.
Yeah, okay.
Let's see. So once you open, open your chat GPT, and at the left, I'll play the video here. 1 second. Okay, so get your chat GPT on, and can you all hear me?
Yeah.
Okay, so on the top left,
We cannot hear a sound from your YouTube, Suresh.
Can you hear my sound?
Not from the YouTube, no.
No? Okay.
It's not coming through.
Okay, so I just walk you through. So what you have to do is okay. So go to your chat box, and on the chat, look on the 2 horizontal bars. Can you hear me, Tarak bhai?
Yeah, I can hear you well.
Yeah. So look on the 2 horizontal bars.
Yeah.
Click on that. Then you'll see your name and your picture at the bottom.
Yeah.
On the left.
Mm-hmm.
So click on your name.
Mm-hmm.
Then you'll see personalization. Can you all see personalization?
I can see that, even though it's free.
Yes. Yes. So click on personalization. Now click on customize ChatGPT.
It's
okay.
Okay.
You are able to see the video, Tarak bhai?
Yeah, I can see the customized chat. I'm looking for that one. So hang on.
Yeah.
I have to go one step back again. Email, personalization, and then customize.
ChatGPT.
It says enable personalization. I hope that will do.
Okay. Maybe.
I may be old one. I may have 4.
Yeah, you have to update it. Yeah.
Yeah.
So whoever
okay,
can see.
I have your thing. You sent it sometime back.
Yeah. Customize ChatGPT. And click on that what traits ChatGPT have, and I posted in the chat. Sorry. Okay, sorry, that was a mistake. Let me see if I can go back. Okay. So let's stop there. What traits should ChatGPT have? Then I put it in the Zoom. If you look on the Zoom chat, I put some, I think five comments. Do you see that?
Yeah, you are my faithful
I put it in the
loyal
chat box.
assistant. Yeah.
Yes.